Welcome everyone to this week's OMR Architecture Meeting. Today we have a couple of topics on the infrastructure side, both proposed by Philip, and I'll turn it over to him to start taking us through those. Philip?
Thanks, Zero. I'm just going to request a screen share. Are you able to see my screen?
You can.
Awesome. So this is just going to be a pretty much kind of an informal walkthrough, not really code architecture related, but nonetheless related to OMR and the build architecture. So the first thing I'm going to talk about is the work we did to add Azure pipeline support for the x86 platforms, Windows, Linux, and macOS. So Azure has partnered with GitHub to provide 10 free concurrent jobs for all open source projects on GitHub. So this is a great resource we can take advantage of. Currently, we only have Travis CI and AppVeyor running for Linux and Windows only. We don't have macOS automated builds unless they're triggered by ourselves via Jenkins. So this was kind of to fill the gap between those. And another thing that's different about the Azure pipelines is that they run the full suite of OMR tests, whereas the Travis and AppVeyor only run either the build or some linting jobs or a small subset of the tests that we run. So Azure pretty much runs the exact same pipeline that we run on our Jenkins builds. So if you fail on Windows, Linux, or Mac, you're going to fail on the Jenkins build as well. So kind of one-to-one mapping. So what's cool about this is that we introduced the concept of caching into the pipeline itself. So this enables us to use Ccache for Linux and Mac OS. Unfortunately, there's no alternative on Windows that we can use to improve up our build times for those two platforms. So with caching enabled, we're actually able to achieve almost a 3x improvement in build times for the entire OMR project. And in fact, we added support to control this by an automated job, which we haven't introduced yet. So you'll notice that the pipeline comes with two files that we contributed. So there's the YAML file, which actually describes the pipeline itself, and there's a cache file. So what this cache file does is it currently just holds a SHA within the repo. And what we do is during the pipeline, we hash this file along with the current architecture we're running, so either Linux or Mac OS, and that determines which Ccache file we load. Unfortunately, due to restrictions of Azure pipelines themselves, the cache that we store is actually read-only, which means that once you've created a cache for a Ccache build, you actually can't write to it the next time you trigger a build. So this kind of gives us a workaround in that we can update this file as we go along to kind of refresh the cache so it'll be populated on the next build. So I'll show you how that works. So if I click on the check mark up above here, I can see that the Azure Pipelines builds are down at the bottom. You can see the AppVeyor build at the top, and I think there's a Travis build somewhere in here as well, right before the Azure. So if I click on the details here, it'll actually bring me to the Actions, GitHub Actions page. So Azure is integrated with the GitHub Actions, so there's two ways to check status, either on the Actions page or go to the Azure pipelines themselves. And the test summary is reported by processing the output of the ctest XML files that we generate. So you can see that there was 190,000 tests ran and all of them passed, which is what we want to see. Now, the interesting stuff is when we dig deeper into the pipeline itself, you can get a whole bunch of different stats for what happens here, the durations of the various builds. So we can take a look at, for example, the Linux job and see all the steps that it does. So this is kind of all encoded inside of the pipeline file or definition itself. So some of the things that we care about here is, for example, the save and restore of the Ccache. So this is the job which hashes that file, the Azure-pipelines cache file that contains the SHA, and then it extracts. So So you can see here, it extracts the Linux version of the cache. So if we ever want to refresh the cache, we can just write to that file and it'll refresh the cache on the next build. We can also automate this, for example, once every week, once every month to just submit a new commit on top of the master just to refresh the cache file. So we can kind of automate that refreshing of the cache. But currently that's not done. It's all manual. So you can see here that once the cache is loaded, there's 190 megs worth of information in there, about 2K files. And once we actually build the project, we upload the stats again, and we can see that roughly 200 or so compilations were hit in the cache. Obviously, we want that number to stay as high as possible. So probably periodically refreshing the cache is really beneficial to the build times. Of course, if you modify like a header file that's very core to the project, like a header file that everyone includes, as soon as that's modified, you're going to start hitting cache misses. So that's not good. We kind of have to keep that in mind when we're writing code to try to limit the number of includes that we actually have. So this is pretty much it. There's a whole bunch of different stats we can gather here. Analytics, for example, how often do we pass the pipeline, how long the pipeline takes on average. This one was pretty interesting. Kind of gives the breakdown of the failures. Are they related to the test or the build itself? Are people contributing? Are the failures due to testing errors, so catching bugs, or is it just compile errors, things like that? So as time goes along, we'll be able to build more and more stats to figure out what kind of problems people are having, and maybe we can improve on that as well. Any questions regarding Azure pipelines? So I guess what the goal was here was to kind of streamline and improve the throughput of feedback on contributors' requests. So I noticed that quite a lot of time people would be waiting for AppFair or Travis CI to complete before they get feedback on whether their tests are, for example, failing, or whether a PR can emerge. So I saw committers even sometimes say, you know what, I'm just not going to wait for AppFair. This thing's going to take forever. I'm just going to merge without letting that check pass. So kind of the Azure pipelines, since it has more resources, the intent was, okay, we can get the information to the contributor much faster. They can see the failures within like a couple of minutes of force pushing to their branch. And it's kind of that instant feedback that we want to get. So eventually, if people get comfortable with Azure, we can propose to phase out the AppFair and Travis CI builds altogether if we want to.
That's looks really cool, Philip. What kind of administrative authority do you need in order to maintain this? Do you need can any committer access Azure, or is all the work that we would normally need to do can be done from within the OMR repo?
Well, if you want to just change the pipeline itself, you can do it by just changing the YAML file. I don't think there's any other maintenance that you would need on the Azure front. But committers do not have access to that. We do have an Azure DevOps organization to which I've added Mark and Charlie as the admins. If any committer though feels the need that they should be part of that organization, we're more than happy to add more people though.
No, actually, that's what I was going to ask. Just as long as it isn't just in one person's in one person's name, as long as it's part of the project, so the project leads have access.
Yeah, the project leads. Yeah.
Okay, cool, good.
Yep. I think the next step here is probably to get the linter jobs as proper jobs in Azure as well. And another goal I think we should have is to get the include what you use job, which runs the include what you use tool on the OMR repo, which we can run periodically, for example, to trigger a build and minimize our set of includes, which will improve the build times.
Mm-hmm.
Hi, hello.
Yes.
Hi, Philip. This is quite cool. I just wondered, maybe I didn't get it. What's the difference, like you using the Azure pipeline from the, like with the, just use the Git action directly? What's the difference between those two?
Sorry, what's the difference between Azure and what?
I mean, you can also like do this, do those work by the Git action directly.
Do you mean by the GitHub action?
Yes.
Okay, I see. I think those are two separate farms. So you're saying that we can run as part of the GitHub action here.
Yes.
I actually don't think there's a difference. It's just the way that you code it. From what I understand, the GitHub Actions, you can either run agents as Node.js or as Docker containers. Azure has workers which have preset tools which you can invoke. So we kind of just ended up using that. I don't think there's a reason. I think it would be equivalent, whichever way we choose.
Yeah, because I think if we directly use the Git action, so you can see the result from the, like in the OMR repo directly. You don't need to like jump to another like Azure.
Right. I mean, that's the page we're looking at right now. This would be an action. This would be the GitHub action. Of course, if you want to dig into the details, you'd have to go to Azure.
Yeah, so because recently I did some Git action build OpenGNI. So I wondered what's the difference from the Azure. Yeah.
Yeah, from what I understand, it's two different build farms. I'm not sure if GitHub Actions would provide the same level of concurrency.
Is GitHub Actions just like the framework for launching these things, and then in this particular case, you're using Azure?
So this was to hook up the GitHub Actions. We actually used the Azure Pipelines GitHub app.
Right. So you could
that does the hookup.
You could add an action for something else, like Jenkins, for example.
Right. Yeah.
Okay.
I think like from the GitHub action, this one is trigger, like go to, like can trigger the Azure build, and we can also trigger the Jenkins, and can also run those like build and test directly on the GitHub hosted machines. So yeah, I think that may be more straightforward, but probably Azure have more support, more powerful, like more support. Maybe I'm not sure.
Yeah, some things like caching is really easy with Azure pipelines. I'll show you in the definition. I'm not sure how equivalent this would be on GitHub Actions. Yeah, because they have a custom CMake job, for example. Yeah, so they have a custom task for creating the cache. I'm not sure if there will be an equivalent in GitHub Actions.
Philip, if there are failures from any of those jobs, what happens to any of the diagnostics that are generated? Is there any way to retrieve them, or do you have to like recreate?
So there are no diagnostics that are saved. Like we don't save core dumps or things like that, for example, because the OMR failures should be at least very deterministic. So you should be able to reproduce all these locally. The only thing that's recorded is the actual job output.
Okay, thanks.
It's the same way that it works on Travis CI and Appware. It's more meant
On
as
Jenkins, I think you just save the XML reports, right?
Yeah, we save the XML reports. We actually parse them at the very end of the job and publish the results. So it gets parsed by the GitHub action.
What platforms are supported here? I saw Mac OS. I saw.
Yeah, unfortunately, it's all the x86 platforms. So the Microsoft hosted runners are all x86, Linux, Windows, and macOS.
Mhm.
I tried to find if we could have AArch64, but they only allow self-hosted runners for AArch.
Okay, so you have to pay for that then.
Yeah, you have to pay for it, or you have to set up your own machine and then hook it up to Azure.
Right.
I don't see the reason to do that since we already have the Jenkins jobs.
Yep.
This was more meant for kind of like the instant feedback to contributors to see if there's anything obviously wrong with their code.
Okay. Any more
Okay.
questions for Philip? Okay. Thanks very much, Philip.
Cool.
I
So I
think
guess
you. Yeah.
so that's
Go
the
ahead.
Azure portion. The second piece is a proposal to add some GitHub Actions to the OMR project. So this is kind of the Actions tab that we talked about just now. We could have done the Azure pipelines as a GitHub Action itself. So GitHub Actions is another free resource that we can use, which is completely free for open source projects. And I believe they kind of use the same infrastructure as the Azure runners do. So it's completely free. They don't really specify though how many parallel jobs, for example, or how many actions can run at the same time, or things like that. So it's not well defined. I have kind of a sense, which I'll explain in a bit, of how much resources they do permit. But it's pretty useful. It doesn't seem to have any restrictions, at least by looking at the docs.
So if with the free tier, you can have 20 concurrent jobs with GitHub Actions.
Okay, cool. That's good to know. Okay, good. I'll talk about some limitations on the types of triggers that I saw. So this is kind of a way to automate and improve the project efficiency on some of the tasks that we commonly do. So I'm proposing to add 3 different GitHub actions, and I'll just kind of walk through each and every one of them. So the first one is to mark stale and close stale issues and PRs. So what I notice is after a while, our project and many other projects, the number of issues and the number of pull requests grow to kind of an unmaintainable amount. And if we look at, for example, the oldest pull request, you'll see that it's probably like a year or 2 old. So it's from July 14th, 2018. Some of these PRs might be stale. Some of them might require quite a lot of work to rebase on top of the current OMR master branch. Some have just maybe been forgotten about or from contributors that are no longer willing to contribute to the project. So we should probably close those off or figure out what to do with them. And similar thing with issues. For example, often people open up an issue, they ask a question, their question gets answered, but they don't close the issue off. So it makes it seem like there's 600 problems in OMR when maybe 100 of these are just questions or something like that. So we should kind of try to do our best to keep the number of pull requests down, as well as the number of issues, and have a healthy pipeline of both coming in and out. And this GitHub action will help achieve that. So what it does is it looks through all the PRs and all the issues, and if it exceeds a certain number of days where nobody has commented on it and there's been no action done to it, what it does is it applies a stale label to the issue, and then it outputs a message saying, this issue has been X number of days old. If you want to keep this issue open, please either comment on the issue or remove the stale label. Otherwise, it's going to be closed in, for example, 30 days. And here's an example of a stale issue and how this thing looks like. So this is just a test issue on my own repo that I created, poked OMR, and created a bunch of pull requests and issues just to test how these things work out. And what you'll see happening is the GitHub Actions bot will come in and say, this issue is 180 days old. It applies a stale label. Now, either committers can remove the stale label if we still want to keep the issue, or if a contributor who doesn't have the power to remove a label, they can just comment on the issue and it will not get removed. This is just kind of a way to keep track of these stale issues. And after 30 days passes, this issue will just automatically be closed by the bot.
Are those numbers configurable?
Yes,
Those
so all
deadlines?
this is completely configurable, and I'll show you exactly how this works. So inside of this GitHub workflow, it's just a YAML file, which actually specifies what action do you want to use. This one's called stale, and it specifies a repository and a version number. So this one comes from the actions / stale repository, and you specify on the message how many days you want to wait before you mark an issue stale, and how many days after that do you want to close it. You can configure the labels as well. So it's really easy to add a GitHub action. It's just a workflow YAML file which specifies what it does. And in the background, what this thing is actually just a Node.js application which works on top of the GitHub APIs to carry out all these tasks. So that's kind of the first one. This one runs as a cron job. So I have it specified, run every hour. So it kicks off a job every hour, scans through a list, applies the labels, yada, yada.
So the action that runs has the authority to make changes to the, like it can add labels and things to the issues, or do we have to give it a special authority for that?
Yeah, so it runs on GitHub tokens. It actually uses the internal GitHub token of the repository to have read and write access.
Okay.
So it's able to apply labels, comment on things, review pretty much anything a committer can do, almost.
I have a concern with that. If that token has write access, then okay, so if, like, for example, this workflow was triggered on a pull request, someone could probably modify this YML file and somehow make some changes to the repository abusing that write access and open a pull request which would trigger that job. Is there something that's preventing that from happening?
Yeah, so that's actually a huge limitation of GitHub Actions, which actually the GitHub folks didn't really envision for whatever reason or not. So what happens on a fork, if you have a fork and you submit a pull request changing one of these files, your token actually gets downgraded from a read-write token to a read-only token, which severely limits what you can do with it. For example, a read-only token, you can't add labels, you can't, I don't think you can even comment, you can't leave review requests, you can't change anything about the repository. So there's no security concern there. This actually severely limits what the GitHub Actions can do. And the next action is kind of a great example of that. So I'll explain now what we did to work around that issue. So the pull request labeler is a GitHub action which labels pull requests based on the files that are changed. So this is kind of a common task for us committers. You go on a PR, a new PR comes along, somebody changed, for example, the port library. Okay, you go inside, you look in the files changed, you see, okay, all of the files are changed in the port library. Let me add the conf port tag to it, or the label to the PR. So this can be actually completely automated by the pull request labeler. So what it does is, again, it scans the list of pull requests coming in and checks what files have been changed, and if it matches a file to a particular label, it just labels the PR. So here's an example of a PR modifying trill tests. So the GitHub Actions bot came in, it saw, this PR is modifying a file inside of the FD test compiler trill test. So it applied the comp test and comp trill labels. And this is, of course, completely configurable as well. If we go back to the root of the repository, again, in the workflow file, there's a label or YAML, and this kind of defines the file change to a label mapping. And I've kind of gone through our set of labels and figured out what kind of things are people marking and which label should be applied to based on the file changed. For example, trill, that one matches any file changed inside of the FV test compiler, trill test, or the other directory. So
So if you're making a fairly pervasive change, let's say that touches a number of, like a single file and number of directories, you could get a lot of labels added to your pull request.
Yes, that's correct. This can be as granular or as coarse as we want it. It's totally up to us.
So if, okay, so this happens when somebody first opens a PR. So if I go and then I change the labels, like I remove the ones that I don't think apply, it won't come around later and then add them back, would it?
I think at the moment it would. I'll have to double check the implementation, but I think at the moment it would. So yeah, that would be one limitation of the GitHub action. It cannot remove labels either. So for example, if somebody accidentally pushes, a change to some file and then the bot comes in and adds a label, and then the contributor realizes, oh, I didn't mean to do that, and they force push a change to remove that change, the label won't be removed. The committer would have to do that. But I mean, that doesn't change even today. Committer would have to manually do that anyways. But yes, I understand your concern about a GitHub or a committer manually wanting to override what the bot does. So I'll talk about the limitation Nazim mentioned right now. I think it's a good point. So this pull request labeler is actually GitHub action, which I created. And the reason why we're not using the upstream one is because of that limitation. So this is called the cron labeler. So the repository explains exactly what the limitation is with the action/labeler. This is the one that GitHub Actions actually advertises to use. And on their repository or on their GitHub action, what they suggest using is a trigger which runs only when the pull request is opened. If you think about it, this is really what you want. You want when the pull request opens, you want to run the labeler, label the files, and then be done with it. This would kind of solve the problem that you mentioned, Daryl, in that if a committer later comes along and removes labels, well, the bot's never going to run on that PR again, so it doesn't matter. But going back to Nazim's question earlier, because of the limitation of your token getting downgraded from a read-write token to a read-only token when you open up a pull request from a fork, this action actually doesn't work. And there's a giant issue here. I think it's issue 12, which is a huge list of people complaining about things not working, and it just goes on and on and on and on. And there's hundreds of people commenting here about this problem, and that's just an inherent problem with how the GitHub action works. And it's unfortunate because kind of all the useful things that you want to do with GitHub Actions is you need write access. So you want to automate some jobs that a committer or someone with higher authority would have wanted to do. So to work around this, what I did was implemented a cron-based labeler, which doesn't run on fork repositories. It actually runs on the repository, on the main repository which you're contributing to. So that kind of works around the issue of somebody trying to do something intrusive with the actual action and trying to introduce some malicious code. So this kind of limits us in how much data we're allowed to process because the cron-based labeler uses the GitHub API, which only allows 30 requests per minute to be completed. So the labeler is kind of or this cron job is kind of aware that I only have a certain number of requests which I can do and a certain number of pull requests that I can process, and it knows about that. So then the next time it runs, it processes different set. So it's kind of a rate aware cron job. Does that answer your question, Nazim?
I was also concerned about the fact that we have a limited. So if the GitHub tokens were being actually used to also use the GitHub API to get the information needed to do this job, there was the GitHub rate limitation in place that we needed to be aware of. So well, thanks for addressing that.
Yeah, so I've configured this one on my test repository to run every 5 minutes. So I'll show you how that looks like. For example, here's another PR modifying the port library Win32. directory, and it chose to add Windows port and x86 to that one. Again, this is just configurable. So the way this works is on the Actions tab, all the cron jobs are listed here. So we have 3 of them, and I've set it to run every 5 minutes. You'll sometimes see that, for example, the pull request labeler. Sometimes GitHub doesn't have enough resources, so it ends up waiting longer than 5 minutes. So this one's, for example, 7 minutes ago and 30 seconds ago. So it's kind of like 6.5 minutes it waited. So I sometimes do see jobs piling up depending on the time of day. Obviously, during core working hours in North America, things are kind of busy and they don't get scheduled on a regular basis. So we're up to kind of the mercy of the GitHub Actions overlords to schedule our jobs in this way.
So one more question. Okay, sorry.
Go ahead, Nazim.
So one more question I had was, you could set up multiple secrets and like to multiple GitHub tokens for each workflow, so that it can we can do more with GitHub Actions, such as let's say something to, for example, do white space checks. So that would require just checking for all the changed files, which would also require using GitHub API. And if it's triggered on a pull request, then it has to, it will be running quite a bit. So maybe we could have, for example, some GitHub token specifically to be used for those GitHub actions that, and then, yeah, so on. So is that something you've considered?
Yep, yeah, we can definitely do that. That would require requesting Eclipse to add additional tokens for us, because we don't have admin rights to our repositories. But yeah, that's certainly something we can consider.
Okay.
Yeah, I think yeah, due to the limitation of the actions tokens getting downgraded, though, it's really, like, for example, the white space check. I'm sure that's a read-only operation, but if you want to act on it, for example, if you want to add a label or submit a comment or something like that, that requires write access. So in which case you wouldn't be able to do that.
It does need to be write access. The script could just return a failure, and that will display a status of failed for that specific job.
Right. Okay. Yeah. Yeah, I agree. We can definitely do that as well.
Can the labeler not add a label if another label already exists? So, for example, I'm not saying that this is what we want to do, but if we already add a label basically saying that this has been automatically labeled, would that prevent subsequent attempts at labeling to fail?
Yeah, we can, of course, we can put in any custom logic. So the labeler is just, yeah, it's just a Node.js job. It's really actually simple. It's just a TypeScript. So we can definitely put in logic into here to check if a label has been applied, and then don't do anything. Basically, just return if that's the case.
Well, actually, if we're assuming that this labeler is only going to be the thing that's going to be applying labels, maybe any issue or pull request that has a label, we just skip it altogether.
Yeah, we can definitely introduce an option to have that available as well. That's a good suggestion. I'll put that on my to-do list.
Question back about security stuff. Can if you have it run on the pull request, can you not configure it to pull the code from master instead of the pull request, and then you wouldn't have to worry about people injecting things?
No, because in order just to be able to run the GitHub action, you need to have a valid token. So I'll if you look inside of the repository for the second or third GitHub Actions here, it references the issues where the folks on the GitHub Action development team talk about. So it's Actions Labeler 12, and I think there's another one for the first-time contributor. I think that one's open as well. Yeah, this one. So I suggest having a read through both of these issues. They're kind of hidden in there, but they're probably the most downvoted answers by the GitHub team on why that wouldn't work. Okay, I think the last action that I'm proposing we add is the first-time contributor. So this one's kind of a welcoming greeting to any new contributors to a project. What I found is in the past, if I look at the contributions from first-time contributors, I usually see a couple of things that are almost always wrong. They don't know that they need to sign the ECA. They don't know even how to do it. They're not adhering to the contribution guidelines for pull requests, and they have no idea where to ask for help. So these are kind of just the three things I was able to think of. Of course, there's probably tons more. We can customize this message in any way we want. So what this GitHub action does, again, it's based on a cron job, which we have to implement, and it just scans a list of pull requests. If it determines that you're a first-time contributor, it just displays a nice welcoming message saying, hey, thanks for the contribution. If you haven't had a chance, please take a look at our guidelines. Or if the ECA check files, go to the legal consideration section to figure out what you need to do to make it pass. And it gives us links to how to interact with the community, join our Slack workspace, etc. And then it marks the label as with the first contribution label, which is something that committers can monitor to make sure that we do review contributions from new contributors promptly, so as to encourage more people to contribute to the project. And this message comes from a markdown document, which we can customize in any way we like. So yeah, that's kind of all the GitHub actions that I thought we should kind of start with just to get our feet wet. I will take the to-do about the labeler and prevent it from applying labels to pull requests which are already have labels present. That should be pretty easy to get done. But other than that, any feedback is welcome. We can just start off with probably one of the GitHub actions and continuously add more as we find them useful. Yeah, that's really all I have.
So when you were talking about the first part about Azure and moving away from Travis CI entirely, so I can immediately see that we can make use of GitHub Actions to run the linter job and use GitHub machines for that. So what do you think of like having that as one of the starting points and then disabling the Travis CI linter job?
Yeah, definitely we can look into that.
Yeah, it doesn't require any tokens or anything. It should be fairly simple.
Yeah, I agree. The linter job is a good candidate. It would require a Docker file.
So we could host something in Docker repository for it to pull. If we have that, we can also probably have other linter jobs that, for example, checks for copyright dates and white space issues and stuff like that.
Yeah, I totally agree.
And can you do, I guess this would also enable some form of feature-based testing as well. And I'll just use Nazim again as an example. So if he contributes an LLJB component to under JIT we could run special testing only if somebody changes something in LLJB, right?
That's correct.
Yeah, so you can specify files like paths that will be part of the trigger parameters. So you can say trigger on pull request on these specific files, or you can even say exclude on for these specific directories, or only run if something is merged into master or something like that. So yeah, for feature-related, feature-specific, or path-specific job triggers, it's pretty trivial to set that up.
So Philip, do all committers see the action tab in the repo?
Yes, yeah, everyone should see it. Even non-committers, all contributors should be able to see it.
Who can add an action? Just committers?
So adding an action is just literally committing a file into the .github/workflows
Okay,
directory.
I get it. Yep. Okay, cool.
So it's just a YAML specification saying, this action uses this this repository, and I'll show you how it looks. For example, so this first interaction. So let's take a look at an example. So this one ran 33 seconds ago. So there's just a job that runs. It sets up the job. So it's just clones the repository and then sets up an Node.js engine and just runs it. Yeah, so there's two ways to run the GitHub Actions. One is with a Node Node application or a Docker file, which runs arbitrary commands.
So one thing that I'd like us to think about, I think the stale labeler is certainly useful for doing this cleanup work on issues. I think that one of my concerns is just not having to continuously go and make sure that things that are created as the backlog of to-do items, making sure they don't get cleaned up, because that seems like an error-prone process, right? Especially given the amount of volume that I get on like GitHub, like trying to sift through all of this would just be another nightmare. I'm wondering if perhaps one way we can think about it is if we are a bit more strict about issues adhering using a template, then perhaps we can be able to use that to key off the ones that are truly issues versus the ones that are opened as actual backlog items.
Yeah, so this job has a bunch of configurations. So one of the ones I highlighted here is you can exempt PRs from getting marked as stale based on messages, based on labels, based on other things. So it's kind of already built into the tool. I know for backlog items, we're pretty vigilant about marking it as such, like help wanted or backlog or something like that.
Yeah.
But I mean, if an issue, for example, if it hasn't been looked at in 2 years, what are the chances it's going to get looked at all? And it's not like it wouldn't appear in their search as well. Like closed issues still appear under search results.
Yeah, I guess the thing is that there are always aspirational things that you would like to do. They're not necessary from a functional perspective now, right? But we need somewhere to remember those things, and trying to sift them out of the closed list also worries me, because trying to find them in the future is going to be hard. Right? The closed bucket gets bigger and bigger.
Yeah, I think we just have to make sure that when those issues are created in the first place, that they're appropriately labeled such that this tool does not treat them as stale. Either it's a bug, or it's something that's in the backlog, or it's something that we need help with. Like, as Philip was saying, as long as it's appropriately labeled, I don't think we'll have a problem with it getting closed.
Yeah, I guess it just means we need some more discipline on that.
Yep.
Any other questions?
I have two questions. So my first one is, when an action is triggered on a pull request, the time that it takes for that action to run, does that get budgeted against the person who opened the pull request or against the OMR project?
It runs on the OMR project, so it gets attributed to the OMR project.
Okay, but they still get the read-only token.
Right. It downgrades from a write to a read-only token.
Okay, and then my other question is, when these action files are committed to OMR and I synchronize my fork, so I have these action files on my repository, that would mean that I get the actions on my fork and they would be running periodically there as well, right?
I believe fork repositories disable actions by default.
Oh, okay, cool.
Explicitly enable them. That won't be a concern.
Cool. That's it.
Thanks, everyone. I'm going to stop sharing and hand it over to you, Daryl.
Okay. So what are the next steps with that one? Like if we were going to consider doing this, would it be like a pull request of like that actions file or something like that?
Yeah.
Let's see.
Well, it depends on which actions we actually want to take in. I've proposed the 3. We don't have to take all of them. We don't have to take any of them. Just up to what we think is the best. But yeah, next would be a pull request to contribute the files.
Okay. Okay. Any more questions for Philip on that? Okay. All right. Thanks, Philip. Okay, that was our last topic for this week. So we'll be back in 2 weeks with another couple of issues to go through. Until then, thanks everyone for joining, and we'll talk again later. Bye.